My name is Noah Gruba. This is my presentation for my computer security course at Metropolitan State University. This is for my Computer Security 332 class. This video is solely for educational purposes and should not be utilized for real-life security implementation. My project is on critical infrastructure and cybersecurity. It's how we can prevent a global standstill. Once again, my name is Noah Gruba. Here we're going to see a brief layout of slides and how this presentation will go. I hope you find it interesting and come out with some understanding of how pivotal the security of these systems are and potentially how we can prevent stuff in the future. We're going to be working in a lot of different fields, and this stuff controls basically our everyday life, and we utilize a lot of this often. So I think it's pivotal. When I'm talking about critical infrastructure, I'm referring to a network of systems, assets, and networks that are essential for our daily lives. It includes things like highways, bridges, railways, utilities, energy, food, water, communication systems, healthcare, and even banking and finance. The importance of these systems can't really be overstated, and as you can imagine, disruption could have severe consequences for national security, the economy, and even public safety. Some concrete examples are roadways, so think things like stoplights, toll booths, public transit systems like rail cars and train systems. It also includes things like energy transportation, so oil pipelines, wind turbines, electrical stations, other obvious things like cell phones and the internet as a whole, uh, and like all banking and finance things. So basically all that stuff runs on or can be considered critical infrastructure. Now that we have a good understanding of what critical infrastructure is and its importance, I want to discuss the vulnerabilities of these systems. Many of the infrastructures rely on industrial control systems and digital technologies to function. Well, this does make it more efficient. It also can introduce risks, mostly because the systems are outdated and were built a long time ago. So tech had to be retrofitted. This means they lack robust security and were not designed with cybersecurity in mind. We also are growing dependence on interconnected systems. So that means that a single breach can have cascading effects across multiple sectors. For example, a cyber attack targeting the energy grid could disrupt transportation, healthcare, and communication systems all at once. Understanding these vulnerabilities can help us design our future systems so we can focus on protection and ensure that these systems remain operational and secure. First one I wanted to take a look at just was a few real world examples so that you can see the real impact that attacks like these can have. The first one is going to be the Ukraine power grid attack of 2015, where over 230,000 people were left without power during a really cold winter. Like I said, in this cyber attack, hackers gained access to the power grid's control system months before anyone realized it. They did this through a spear phishing campaign where they sent emails to employees that tricked them into downloading a piece of malware known as black energy. This malware allowed the attackers to infiltrate the system and remain undetected for months, all while they've identified vulnerabilities. They exploited outdated systems and weak security measures so they could gain full access over the grid. On December 23rd, the attackers launched the coordinated strike using remote access to disconnect power substations across the country. The result was a massive power outage that left over 230,000 people without the electricity during a bitter cold winter. This attack was a wake-up call for a lot of people. It demonstrates the severe societal impact of exploiting weaknesses in industrial control systems. It also highlights the importance of proactive measures, particularly in employee training, so you can recognize and respond to phishing attacks. Furthermore, it underscores the dangers of interconnected infrastructure and the critical need for the proper segmentation so you can isolate and protect essential systems. Another one I wanted to take a look at was in May 2021, the Colonial Pipeline. It is a key fuel supplier for the East Coast, where they supply over 45% of the fuel used. They fell victim to a ransomware attack. The attackers used malicious software to get access via a compromised VPN account. They then encrypted critical data, forcing the company to shut down operations, which in turn, with this attack, disrupted fuel supplies for days and caused widespread panic and economic losses. The Colonial Pipeline ransomware attack disrupted operations for several days. The attackers, identified as the Dark Side Group, gained access to the pipeline's IT systems through a deployed ransomware that encrypted critical data. As a precaution, the pipeline's operational technology systems were shut down, which caused widespread fuel shortages across the East Coast, creating panic and significantly impacting businesses and consumers. The attack highlighted vulnerabilities in the intersection of IT and OT systems with critical infrastructure. OT being operational technology, so more the hardware sides of stuff. The incident demonstrated the importance of securing IT systems to prevent breaches that could affect operational systems. It also underscored the need for strong incident response plans and improved ransomware defenses. Things like a better network segmentation, data backups, and threat intelligence sharing. So just communicating between companies, government agencies, things like that. The next one I wanted to take a look at was also in 2021. It was the Oldsmar water treatment plant in Florida. They became a target of a significant cyber attack that demonstrated some vulnerabilities of poorly secured critical infrastructure. The attackers gained access to the plant's control systems through insecure remote access software, which was still in use despite its known risks. Once inside, they attempted to alter the chemical composition of the water supply by increasing the levels of sodium hydroxide to 100 times the safe limit. Sodium hydroxide is used in small amounts to control the water acidity, but at such a high concentration, it becomes highly toxic and could have posed a severe public health risk. Fortunately, an alert plant operator noticed the changes in real time and immediately reversed them before any harm occurred. However, the incident highlighted several key vulnerabilities. The remote access system lacked multi-factor authentication, making it an easy entry point for attackers. There were also no automated monitoring systems to flag an attack like that. The attack could have had devastating consequences if not for the operator's vigilance. It serves as a reminder that even small facilities are vulnerable to cyber attacks and that reliance on manual detection is not enough. The Florida water plant incident highlighted the need for things like securing remote access points with stronger authentication, implementing real-time monitoring tools, and providing employees with comprehensive security training. It also demonstrates the importance of regularly auditing and updating all systems to prevent similar breaches in the future. So what can be done to prevent things like this in the future? I think generally with a lot of this stuff, it's going to be learning from our mistakes and just improving and implementing new measures to make sure we don't have same issues that we've had previously. There are many things that can be learned, but what we can take from the Ukraine power grid attack, the Colonial Pipeline ransomware incident, and the Florida water treatment breach is they highlight vulnerabilities in critical infrastructure. While the methods varied from phishing to compromised credentials and weak remote access, the underlying issues were the same: lack of proactive cybersecurity measures. To mitigate these risks, we must prioritize security across all fronts. Employee training is critical to prevent attacks like the Ukraine breach, where phishing emails gave attackers initial access. Better remote access policies, including multi-factor authentication, could have stopped the Florida water treatment attack. And in cases like Colonial Pipeline, network segmentation and zero trust architecture would have limited the spread of ransomware. Real-time monitoring is another essential tool. Anomalies in system behavior can be seen in all the three cases and need to be detected early to prevent escalation. Additionally, upgrading legacy systems and enforcing patches can close vulnerabilities that attackers often exploit. Finally, incident response plans must be a top priority. The faster we can identify and contain and recover from an attack, the less disruption it causes. With these measures, we can build resilience into critical systems, ensuring they remain secure even in the face of evolving cyber threats. Thank you guys for watching. I hope you took something good away from this. If you have any questions, please feel free to reach out. My email is there. It's ns4771rv@go.minstate.edu. Thank you.